Hello everyone, my name is Anderson, aka Charlie, and in this video I will go over a walkthrough of the multiple choice section of the AP Physics C Mechanics 2017 exam. So what to expect from this session? The session will give a detailed walkthrough of the multiple choice section of the 2017 AP Physics C Mechanics exam, link in description. The purpose of this session is to help you prepare for the exam, and the timestamps are given for those who need it. So my qualifications, here are my SAT and AP scores, yada yada yada, I don't really need to focus too much on it. I'm also a certified tutor through schoolhouse.world, which is an online tutoring platform. Yeah. So why did I decide to make this video? I know that study resource videos aren't the type of video that I usually post, because you know I usually post memes and gaming videos, but I decided to make this just because why not, I guess. So here's the AP Physics C formula sheet that you will be given on the exam. When you take the exam, you get the formula sheet for both mechanics and electricity and magnetism. You're also allowed to use a calculator during the exam. Now, most of these formulas you should have already memorized or at least know intuitively. But the formula sheet is definitely helpful, and a lot of this is I feel like unnecessary, but it's still given to you just because, like, why not? Anyway, so now they also give you a lot of constants and symbol meanings, unit symbols in the AP formula sheet, along with the values of basic trigonometric functions, which I feel like is a lot of this is kind of unnecessary because you're allowed to use a calculator, and a lot of this should be common knowledge, but I mean, you're still given it. But anyways, without further ado, let's just get into the questions. Question 1. A plane starts at rest on a straight runway. For the first 30 seconds, the plane's acceleration a is given as a function of time by the equation a equals beta t squared, where beta is 1 over 90 meters per second to the 4th power, and t is in seconds. What is the plane's speed at t equals 30 seconds? So for this, this is basically just a calculus problem. You have the acceleration is equal to beta times t squared, which is equal to 1 over 90 times t squared, that's beta, and you just take the integral of the acceleration with respect to time, which gives you the velocity with respect to time, which is this. You plug in 30 and you get 100, which makes the answer C. Question 2 is more of a concept question, so this question shouldn't be too hard. I'll give you some time to read through the question, and then I'll explain it. Okay, I think you've probably read through the question now. I think I've given ample time. So the answer is C, and basically, so from student one's perspective, he is moving with a velocity towards the right. When he drops the ball is also moving with that same velocity to the right. And so from student one's perspective, the ball is just falling straight down. From student two's perspective, the ball is gaining velocity from gravity downwards and is moving rightwards at a constant speed. That is if you neglect air resistance. So question 2, not that hard, the answer is C. Question 3, I'll give you a few seconds to read the question and then I'll go over it. So basically the answer to this question is, okay, ignore the letter E, the answer is actually D. Just ignore the letter E, that was a mistake. So the answer is actually D, and basically the magnitude of the angular momentum with respect to the origin is, so angular momentum is r cross p. So the radius vector cross the p, so p, which is momentum vector, So, how do I say this? So momentum, like linear momentum, is mass times velocity, so 2 times 0.8. And then r, so r at the particle's starting coordinate x equals negative 3m, it would be right here. Keep in mind that like it's along this line, which is y equals 4m. So at the start, it would be right here, which it would have a radius with the origin of 5. However, since we're doing the cross product with the momentum, and since the momentum points rightward, you're only taking the part of the radius that's perpendicular to the momentum, which is 4, which has a length of 4. So that's why you have 4 times 2 times 0.8, which is 6.4, so the answer is D. And this equation is on the formula sheet, so you don't have to memorize it, even though I'm pretty sure you probably intuitively know it by now. Anyway, next question, 4. Suppose that a spherical star spinning at an initial angular velocity omega suddenly collapses to half its original radius without any loss of mass. Assume the star has uniform density before and after the collapse. What will the angular velocity of the star be after the collapse? So this question isn't that hard. It's just a conservation of angular momentum question. So angular momentum can also be written in these units: the rotational inertia times the angular velocity. And the rotational inertia times angular velocity before and after the collapse have to be the same, because it's conservation of angular momentum. Now the moment of inertia, aka rotational inertia, of any sphere is 2 over 5 times mr squared, and then times the velocity, the angular velocity, which is omega 1. So the 2 over 5m gets to cancel out, because like the mass stays the same. So here you're just left with, oh yeah, and since the radius collapses to half, the r2 is equal to r1 over 2, so you end up getting r1 squared times omega 1 equals r1 squared over 4 times omega 2, and then the r1 squared cancels out, and then you end up getting omega 2 is equal to 4 times omega 1. So the angular velocity after the collapse, which is omega 2, will be 4 times omega 1. The answer is E. Now question 5, I'll give you 10 seconds to read the question and then I'll explain it. So basically, this question shouldn't be that hard because it says astronauts in an orbiting space station, so there's no gravity there. Well, okay, there is gravity, but there's only microgravity, which I guess can be ignored. So a lot of the answers wouldn't make sense because like toss the box straight up, they don't come back down. On opposite sides of a balance, there's no gravity, so they have no weight, so a balance wouldn't work. Push each box, this sounds like the correct answer at first, but the box with the tooth will travel further. No, they don't stop traveling, because there's nothing stopping them from traveling. An object in motion stays in motion. Weigh each box on a spring scale. Again, there's no weight in space because there's no gravity. So the only correct answer is to shake each box. So, because more force is required to move a box if it has more mass. Because remember, force equals mass times acceleration. So if there's more mass, then it requires a greater force to accelerate the box by a certain amount. Next question, question 6. A block of mass m1 is connected by a string to a sphere of mass m2. The block is on a frictionless plane inclined at an angle of 30 degrees as is shown in the figure above. The string passes over a pulley of negligible mass and friction, and the sphere hangs freely. Which of the following is always true if the block is accelerating down the incline? So if the block is accelerating down the incline, what that means is that this block exerts a greater force onto the string than the sphere, the mass of the sphere. So the correct answer is E, because m1 times sine 30 is the weight of the block. Cause like so in m2 is just the mass, the mass of the block. Well, yeah. So like the mass, like the weight is mass times gravity. So m2 has gravity pulling downwards times m2, and for block m1, it since it's on a 30-degree incline from the horizontal, then you do sine 30, because like that's the ratio of the, yeah. So question 6, the answer to question 6 is E. Question 7, again I'll give you 10 seconds to read it and then I'll go over the answer. So the correct answer is 7, conservation of momentum, B. So conservation of, well, magnitude of momentum. So basically how it works, so remember that momentum is always conserved whenever there's like a collision or explosion, quote unquote explosion, or any sort of thing like that. And yes, I understand that the spring would like give the two cards like more velocity, but like the cards end up going in opposite directions, so their velocities kinda cancel out, if you know what I mean. And kinetic energy definitely increases because like the spring was initially compressed and it was released, which like gave the cards the kinetic energy. So kinetic energy definitely increased because like energy from the spring was transformed to the cards. So yeah. So the answer to question 7 is B. Question 8, I'll give you 10 seconds to read through and then I'll tell you, and yeah. So the answer to question 8 is E, and it should be pretty like self-explanatory. It's just that you can't determine it without knowing how long the, like, it asks what is the magnitude of the average force applied by the floor, but that depends on how long how the duration of the force, because like the total force, because like it rebounds to its original height, so it must change its velocity, like it must have the same velocity going upwards as it had when right before it reached the ground downwards. So the total force, but it's a matter of like how much time the ball had been in contact with the floor in the ball, and you don't know that. So the answer is E. Questions 9 and 10 go together. I'll give you 20 seconds to read through this and then I'll go over the answer. Alright, so the answer to questions 9 and 10 are both B, and the reasoning for question 9 is conservation of momentum. So remember that at the time, so at time t equals t1, particle A is observed to be traveling with speed 2v0 or 2v naught over 3 to the left. The speed and direction of the motion of particle B must also, the momentum must be the same before and after they have exerted the forces on each other. So originally, so the two particles have the same mass, and originally particle A was going velocity v naught to the left. So at the end, the total mass times total velocity must stay the same. Since the total mass stays the same, then the total velocity must also stay the same. So in order for that to add up to v0, the answer has to be b, the velocity of particle b, and they add together. So it's v0 over 3 to the left. Now, question 10 is actually super hard, and it's not really, like, of course, many people are definitely going to be very confused by question 10, and if you're confused by it, don't worry, you could probably just skip it, and like, because like question 10 isn't the type of question that you should expect to see on this exam. Like, they're not supposed to be that hard. And question 10 kind of goes into electricity and magnetism, because I'm assuming these two particles are like protons protons, or they're both electrons. Anyway, so which of the following equations could be used to find the minimum distance between the masses as particle A approaches particle B? Well, for one, for the two masses, if you look at my camera, so the closer they are to each other, the more force there is. And what happens is that at the minimum distance, the two particles, they must like go like, they must both be traveling at the same velocity, v0 over 2, when they are like both about to, when they are at the minimum distance. And I don't really know how to explain this. It's just that like intuition should tell you, because the force pushing the two particles apart gets the stronger and stronger the closer they are to each other. And right at the midpoint, when both particles have the same velocity, v0 over 2, that's like, it's hard for me to explain, but like, you get a point, right? So, and another thing is that potential plus kinetic energy must stay the same. And kinetic energy on the formula sheet is 1/2 mv squared, which in this case is m, and potential energy is given here, U equals beta over r squared. So in order to find this, this is the left-hand side of the equation is the potential energy before at the start, and the right is the total energy. Sorry, not just the potential. It's the potential plus kinetic energy at the start. The right-hand side of the equation is the potential plus kinetic energy afterward. So before the potential energy at the start is a beta over 2d, that in parentheses squared, because the distance between these two is 2d, and the kinetic energy is just 1/2 mv0 squared, because like, you know, yeah. And the potential and kinetic energy combined after the collision, I mean like in the midpoint, when the two particles are like at the minimum distance, should be beta over r min squared, because like, you know, the potential energy equation, plus 1/2 mv0 over 2 squared, because both particles are traveling at v0 over 2, at the velocity v0 over 2, and since there are two of them, you multiply by 2. So that is why answer choice B is the correct answer. Because like during r min, they both move at speed half of v0. This question, again, I will say that this question is really hard. It's like harder than normal questions on this exam. So you don't really have to worry too much about questions like this, because like this is like an outlier in terms of difficulty. Because like, yeah. Anyway, next question. Question 11. I'll give you 10 seconds to read through, and yeah. So, one way to find the kinetic energy could be to calculate the work done on the object. So the work done on an object is the change in energy, change in kinetic energy in this case, of the object. And since you know the object was released from rest, you know that the object had 0 kinetic energy to begin with. So therefore, the work done on the object would be the same as the kinetic energy the object has at the height of 1 meter. In the work, assuming, like since it says from the Earth's surface, you know that the acceleration is 10. The force is the mg, 2 kilograms times gravity. So you know the force is constant, and you know the force, and you know the distance traveled by the object. So you have force times distance. You know the work done on the object, so you can calculate the kinetic energy. However, you could also calculate the velocity at that point, and then solve for 1/2 mv squared equals kinetic energy, which is here. And you could use this equation, which is given on the formula sheet, to solve that. And you end up getting 40, which is the same answer, different method. The answer is E. So, yeah. Next question. I'll give you 10 seconds to read it, and then I'll go over the answer. Okay, so, I don't know why it didn't have the diagram. I don't know why it's not appearing in my slides, but I just drew a diagram here, so you know what it is. So this sphere is hanging from 2 strings that make an angle of 30 degrees with the ceiling, the horizontal. And what is the tension in one of the strings? Well, you know that there's a gravity, the force of gravity, and the force of gravity is mg pointing downwards. So therefore you know that the 2 strings have to negate the force of gravity, because the sphere is hanging and not moving. So you know that there must be 0 acceleration, meaning that the force of gravity pointing downwards must be negated by the tension in the 2 strings. So mg equals 2 times tension sine theta. So T is the tension in one of the strings. Since there are 2 strings, that gives you 2 times T. So both of the tensions combined. And the tension in one string times the sine of the angle with the horizontal would be the vertical component of the force of tension in that string. So from this equation, you end up getting the tension equals mg. So the answer is D. Because you use this equation because you know that the net force is 0, so the forces cancel out and are equal. So yeah. So answer to question 12 is D. Question 13. I'll give you 10 seconds to read over it, and then I'll go over the answer. So, this one, you could probably already solve it through intuition. You probably don't need to do the calculations. However, I'll just tell you the calculations anyway, because, like, why not? Well, okay, there are some reasons not to, because, like, you'll run out of time, but, like, I'll just go over the calculations. So, the skier, let's just use a box, a square to represent the skier. It's much simpler. The slope is inclined 30 degrees above the horizontal. Now you know there must be a force of gravity pointing downwards, which is mg, the mass of the skier times gravity. And then the normal force, and then you know there's a normal force which would point perpendicular to the slope, to the incline. And the normal force is just the force of gravity times cosine of the angle, which is 30 degrees. And then the net force, the forces combined together is just mg times the sine of the angle, which is 30 degrees, and that points down the incline. So, however, the acceleration is equal to force over mass. So, like, the mass cancels out. So then you get g times sine 30. And then since there's kinetic friction, which is the coefficient of that kinetic friction is 0.1. So therefore the acceleration is the force, is the net force and the net force includes the force of friction being subtracted, like the force of friction counteracting partially with this force. So the force of friction, mu kinetic friction, mu k times the normal force. That's the force of friction. The force of friction is the normal force times the coefficient of kinetic friction, and you solve this and you end up getting roughly 4. Now you could probably just use process of elimination anyway, because like you know it can't be 0 because there's acceleration obviously, and it can't be 9 or 10 meters per second squared because that would be the acceleration of a free fall, in the sense like, you know, it's 30 degrees with above the horizontal. There's no way that's a free fall. So you could probably just use process of elimination to get the answer B, but you could also calculate it. Question 14 through 16 go together, and I'll give you 20 seconds to read through it, and then I'll talk about the answer. Anyway, so what is the ball's acceleration at time t equals 1 second? Well, the acceleration is always gravity, and there's no other force acting on the ball. Assuming that air resistance is negligible, there's no force but gravity acting on the ball, so the force of acceleration at any time would be negative 10 meters per second squared. And it's negative because they tell you that, because in the context of this question, the positive direction is upwards, and since gravity points downwards, then it's negative 10 meters per second squared. The answer to question 15, at what time does the ball reach its maximum height above the building? Now you know the velocity, which is this, and you could integrate the velocity with respect to time to get a position, y position, and then like find them and then graph it and find a maximum. But if you know calculus, which I'm assuming you should know, you know that when the velocity goes from positive to negative, that's a relative maximum, and the relative maximum here is the only maximum. So basically whenever v of t is 0 and it goes from positive to negative, you know that it's the relative maximum. And when is v of t equal to 0? Well, v of t is equal to 0 when t is equal to 0.5. If you look at this equation, v of t is equal to r minus st. V of t is equal to 5 minus 10t. So when t is 0.5, the ball is at its maximum height, which is so the answer to question 15 is a C. The answer to question 16, and ignore this 2, I don't know why this 2 is here. Well, yeah. The answer to question 16, if the ball reaches the ground at t equals 2 seconds, what is the height of the building? Well, I'm gonna integrate, well, the way I solved it is I took the velocity, the velocity function, and integrated it with respect to time, which that's how I got the position function, which is this. And when t equals 2, and this is the, so I got the position function, which is 5t minus 5t squared, and this is the y position relative to the top of the building. All right, it's the y position relative to the top of the building. So, and then, so I just want to find the y position of the ball relative to the top of the building at t equals 2 seconds, which is when it reaches the ground, and that is the height of the building. And when I plug 2 in for t, I get negative 10. So the distance between, so the distance from the top of the building to the ground is negative 10 meters. But it's positive 10. The answer is positive 10, which is B, because it's asking for the height of the building, not the distance between the building, the ground and the top. But like, you get a point, right? Yeah, so the answer is B. Questions 17 through 19 go together, and I'm gonna give you 30 seconds to read through this, and then I'll go over the answer. Alright, so question 17. The answer to question 17 is B, because it asks which must be conserved, which is angular momentum. Remember, conservation of angular momentum. Angular momentum is conserved and has to be conserved. And it's B, only angular momentum, because the kinetic energy may or may not be conserved. Because, like, you know, kinetic energy may or may not be conserved. So, nextly, the answer to question 18. So the interval of time, you've read this. I hope you read this question during the 30 seconds. Anyway, so which of the following expressions gives the magnitude of the average torque that the first disk exerts on the second disk? So torque is equal to rotational inertia times angular acceleration. And the integral of torque with respect to time is equal to the total change in, like, how this is equal to the total change in omega times the rotational inertia, which rotational inertia is mr squared over 2. It tells you the rotational inertia is mr squared over 2. So the total change in rotational momentum is the angular speed, angular velocity times the rotational inertia, and you know that must be equal to the torque. So, and then if you take the derivative of both sides with respect to t, you go back to torque. You go from integral torque dt back to torque, and then here you get delta t, and therefore you get the answer here at the right hand side of the equation. At the right hand side of the equation, the answer is mr squared omega final, which is angular velocity final, over 2 delta t. So the answer to question 18 is C. And the answer to question 19, this one you kind of just have to like know rotational inertia. If the disks are shifted so that the axis of rotation goes through the point on the edge of the disks, then the rotational inertia becomes 3mr squared. For this one, you just, how do I say this? So, because, like, remember that the rotational inertia, there are two disks, so multiply by 2, and then multiply by 3, like, yeah, you just kind of have to, like, know the rotational inertia of different rotating objects, I guess. They don't give that to you on the formula sheet, so, yeah, unfortunately. Anyways, next, question 20. I'll give you 10 seconds to read the question, and then I'll go over the answer. Okay, so the answer to this question is pretty simple. It's A, because so assuming air resistance is negligible, the only force acting on the object, acting on the metal sphere throughout its entire path, is just the force of gravity. Gravity is the only force acting on the metal sphere throughout its entire path, and that means the acceleration must be the only force acting on it throughout its entire path. And the acceleration is constant because it's gravity, it's constant acceleration. So the answer is A. Yeah, constant acceleration, because constant gravity. So yeah. Question 20. A cannonball is shot from the top of a 30-meter high hill at a velocity of 25 meters per second and at an angle of 40 degrees above the horizontal and lands on the ground below. The speed of the cannonball at the top of its path is most nearly what? So, the cannonball is shot at a velocity of 25 meters per second and at an angle of 40 degrees above the horizontal. Now, the 30-meter high hill, that is extraneous. I don't really know why they give you that info. That doesn't really matter. This info doesn't really matter. But the speed of the cannonball at the top of its path when the cannonball is at the top of the path, that means the cannonball has no vertical velocity. That means the only component of a velocity that a cannonball has is horizontal velocity. And horizontal velocity stays the same throughout the entire path, because assuming air resistance is negligible, the horizontal velocity remains the same throughout the entire path. And since there's no vertical velocity at the top of its path, you just calculate the horizontal velocity, and that's the speed of the cannonball at the top of the path. And the horizontal velocity is just the initial velocity times the angle at which it is shot at. Sorry, not times the angle, times cosine of the angle with which the ball is shot at. So 25 times cosine 40 degrees is approximately equal to 19. So 19 meters per second. The answer is C. Question 22. A 1,500 kilogram car is pushing a 4,000 kilogram truck. The car and truck are accelerating at 2 meters per second. Yada yada yada. What is the force the truck? What force is the truck exerting on the car? So, according to Newton's third law of motion, every force has an equal and opposite counter force. So, the truck is accelerating at 2 meters per second, and the truck has 4,000 kilograms of mass. So force equals mass times acceleration. Force equals 4,000 kilograms times 2 meters per second squared, which is 8,000 newtons. That is the force on the truck. So that is the force that the car exerts on the truck. And since the car exerts that force on the truck, that means the truck must also exert that force on the car, according to Newton's third law. So the answer is D, 8,000 newtons. So question 23 should be pretty simple. It's just three forces like accelerations that are acting on this object. So the force pointing upwards cancels out. So part of the force pointing upwards cancels out with the force pointing downwards, and there's also force pointing to the right. So therefore the net acceleration, net force on the object is just a little bit of force pointing up and some force pointing to the right. So the answer is A. Now questions 24 through 26 go together, so I'll give you 30 seconds to read through them, and then yeah. Alright, so question 24. So the answer to question 24, the ratio of the speed v1 to v2. So v1 is the speed of mass 1, v2 is the speed of mass 2. The ratio of the speeds is a square root of r2 over r1. The reason why is because of this. So with gravitation, well, for one, when an object rotates around another object, there is constant acceleration pulling inward. So when mass 1 rotates around the center object, the mass 1 has constant speed, but it's constantly being accelerated inward. It's constantly being accelerated inward. So now in the acceleration in a circle is equal to the velocity, the linear velocity squared over r, the radius. And also, since we know that the acceleration of mass 1 is equal to the acceleration of mass 2 times the square of the ratio of the radii, then we know this equation. And then we also, from this generic equation, v squared over r equals a, we derive v1 squared over r1 is equal to a1, and same goes with object 2. And then from here we know that a1 is equal to this, is equal to the square root, is equal to the square of the ratio of the two radii times a2. So a1 is equal to v2 squared over r2 times r2 squared over r1 squared. And then the r2 squared here and the r2, these two cancel out. And you end up getting v2 squared times r2 over r1 squared over r1 squared. And we know that a1 is the same as v1 squared over r1, so we have this, and then the r1 here, the r1s cancel out, and we get v1 squared equals this, and then after that we divide both sides by v2 squared, and we end up getting this. And then we take the square root of both sides, and we end up getting v1 over v2 is equal to the square root of r2 over r1. And that's what they're asking for. They're asking for the ratio v1 over v2, and that is the square root of r2 over r1. So the answer to question 24 is A. So the answer to question 25 is D. And the reason why is because it's asking for the magnitude of the angular momentum of the two satellite system. And the angular momentum, angular momentum in this case, the magnitude of the angular momentum of the two satellite system. So angular momentum is just mvr, mass times velocity times radius. Well, it's also the angular momentum, because However, since the two objects are rotating in opposite directions, since m1 is rotating counterclockwise, and since m2 is rotating clockwise, then it's their momentums subtracted from each other. So the answer is D. Now for question 26, it asks this. I'm sure you've read it during the 30 seconds I gave you. So on the formula sheet, they give you the formula for gravitational potential energy, which is negative g m1 times m2 over r, g being the gravitational constant. So when you have the ratio u1 over u2, the gravitational constant and the negative sign cancel out in the u1 and u2. And the m1, which is the mass of the center of the planet, also cancels out. So you end up getting m1 times r2 over m2 times r1. So, you end up getting m1 r1. You end up getting m1 over r1 times m1 over r1 divided by m2 over r2, and that can be rearranged to get the expression C, which is m1 r2 over m2 r1. So the answer to question 26 is C. Question 27. The graph above shows a variable force F that acts on an object as it moves along a straight line as a function of time t. What is the change in momentum of the object from t equals 2 seconds to t equals 4 seconds? So on the formula sheet, they give you the formula for change in momentum in terms of time and force. So the integral of the force with respect to time is the change in momentum, and it asks from time t equals 2 seconds to t equals 4 seconds. So the change in force from 2 to 4 is the change in momentum. And according to the graph, the force and the time are the same. So it's just the integral from 2 to 4 of t dt, that is the change in momentum, and that is equal to 6. I'm sure you know how to do calculus and find the 6. So the answer is D, 6 kilograms times meters per second. So question 28, I'll give you 10 seconds to read the question, and then I'll go over the answer. So the answer to this question is B, and this is another conservation of momentum question. I've noticed that on this AP exam, so many questions rely on the understanding of conservation of momentum during a collision. I don't know why, but I don't know if this applies to every AP Physics C mechanics exam, but like it definitely appears a lot. Anyway, so the blocks are M, 2M, and 3M. So at first, only block A, which has a mass of M, is moving, and later on, blocks A, B, and C, which has a combined mass of a 6M, are moving together. Now, conservation of momentum means that momentum must stay the same before and after the collision. So, and we also know, so I'm just gonna say M1 is equal to the mass before the collision, and the mass before the collision is just the mass of block A. M2 is the mass after the collision, which is the mass of blocks A, B, and C combined. So M2 is equal to 6M1, and through conservation of momentum, we know that we can cancel out this, and we end up getting V1 equals 6V2. V1 being the velocity before the two collisions, V2 being the velocity after the two collisions, and we end up knowing that V2 is equal to V1 over 6, so the answer is B. V, the speed of block C, and oh yeah, after the collisions, the speed of the three blocks are the same. Since the three blocks stick to each other, they must have the same velocity, the same speed, so the speed of a block C after the collisions is V over 6. B is the answer. Now, question 29 should be pretty self-explanatory. The answer is obviously A, because the force, there's constant negative force. Like, if you see, there's negative force, and it's not constant. Sorry, I didn't mean constant. It's negative force that, like, with respect to position, and like, you know, yeah, so, and since it's the only force acting on the object, then the potential energy of the system as the object moves from 0 to 0.1 has to increase only. This one should be pretty self-explanatory, so yeah, let's move on. Question 30. How does the work required to accelerate a particle from 10 meters per second to 20 meters per second compare to that required to accelerate the same particle from 20 meters per second to 30 meters per second? So the answer is A, it is less, and that is because the work is equal to the integral of force with respect to the distance. And so the force, the total force exerted onto the object is the same. The total force for both scenarios, the total force which is mass times acceleration, and the total acceleration from 10 meters per second to 20 meters per second is an acceleration of 10, which is the same acceleration here. So the total force is the same. However, when an object accelerates from 20 meters per second to 30, it travels a much greater distance, so there's much more work being done. So the answer is A, because the work accelerating the particle from 10 to 20 meters per second is much less than the work accelerating it from 20 to 30 meters per second. Now, work is also the change in energy, change in kinetic energy of the object, of the particle, and the change in kinetic energy is m1/2 mv squared, and obviously you know that from when the velocity goes from 10 to 20, v squared increases by some amount, which is less than the amount with which v squared increases when it goes from 20 to 30. That is another way to solve the problem. There are many ways to solve this problem, but regardless of what method you use, the answer is A. It is less. Questions 31 and 32 go together, so I'll give you 20 seconds to read through it. Okay, so the answer to question 31 is E. So the reason why, so first of all, when a particle is rotating, it has the acceleration pointing towards the center with which the particle is rotating. That's the acceleration of the particle pointing towards the center. So since the particle is at the top of the circle, it's pointing downwards. However, the particle is also speeding up because the angular speed of the particle is given as a function of time t equals omega of t is equal to bt, where b is a positive constant. That means that as t goes up, as in as time passes, the omega also goes up, the angular speed also goes up, meaning that the particle is moving faster and faster. The particle is gaining speed. So therefore, the particle's force must also have a component pointing towards the left, because the particle is, at this point, it's moving towards the left and it's speeding up. So it must have a component of acceleration directed downwards and to the left, because it's spinning around this circle, it's spinning in the circle, and it's speeding up. So it must have these two components. For question 32, it's asking about the angular momentum as a function of time. So angular momentum is equal to the rotational inertia times the angular velocity, which is I omega. Now we know that omega is equal to bt, that's what they gave you here. And for an object, the rotational inertia is equal to mr squared. So rotational inertia, which is mr squared, times omega, which is bt, equals mr squared bt. So the answer is C, which is mr squared bt. That is the angular momentum of the particle. Questions 33 and 35 go together. I'll give you 20 seconds to read over it, and then we'll go on. Anyway, so what is the position of the object at t equals 3 seconds? Well, the object is pulled down 15 centimeters, and it oscillates with a period of 2 seconds. That means that the object from right here, so every 2 seconds there's one period, meaning that every 2 seconds the object goes back here. So that means in 1 second the object would go from here to the top of its oscillation, and then in 2 seconds the object would go from the top of its oscillation back to the bottom, and in 3 seconds the object would then go from the bottom of its oscillation back to the top. So the position of the object at t equals 3 seconds is at the top of and so that means 15 centimeters, the top, and it's at the end. They say let the positive direction be upward, so upwards would be at the top 15 centimeters. So the answer to 33 is A. Now the answer to 34, 34 asks what is the total distance traveled by the object during the first 2 seconds of its motion. So during the first 2 seconds of its motion, the object completed one complete period of 2 seconds. So the object goes from here to here and then back to here, which that is one complete period. So in this period there's it traveled 15 centimeters, 15 more centimeters, 15 more centimeters, and 15 more, because like it travels 15 centimeters twice. So it's 15 times 2 times 2 equals 60, so 60 centimeters. This shouldn't be that hard. It should be pretty intuitive, but like if it's not, that's fine. Then this is how I do it. Anyway, now for the last question. Which of the following statements is true of the magnitude of this acceleration of the object at time equals t equals 1 second? So at time t equals 1 second, the object is at the very top of its oscillation. So therefore the acceleration must be pointing downwards with maximum value, because like you know, the spring with a simple with an oscillation of a string, the more displaced the spring is from its equilibrium position, the more acceleration it has. And at time t equals 1 second, it has the most displacement from its equilibrium position. So therefore, the answer is D. The answer to question 35 is D. It has maximum value because it has the most displacement at like the object. Yeah. So anyway, this is it for the multiple choice section of the AP Physics C Mechanics exam. Thank you for watching my AP Physics C Mechanics walkthrough / tutorial video. I hope my video helped you prepare for the AP exam. If so, if you've made it this far into this video, this means you definitely enjoyed it, so be sure to hit the like button, subscribe to my channel, hit the bell icon to never miss another upload, and if you have any lingering questions, or if you have anything you're confused with or need help with, feel free to leave a comment asking me anything about the exam. I will respond as quickly as possible. But anyways, this has been Charlie. Thank you so much for watching my video. Let's go to the end screen, I guess. Now, for those of you who don't know my channel well, I know I am deviating from my usual videos. I usually post memes and gaming. This is because I am experimenting with different types of videos to see if I can get more views, and if my steady tutorial videos do well, I'll upload more tutorial videos, perhaps of different AP exams and the SAT. And if you're new to my channel, feel free to check out my gaming and meme videos. But anyways, this has been Charlie. Thank you so much for watching. Until next time, take care. Okay, this is awkward. Let me just end this video right here.